Hi, my name is Sebastian Malden, and today I'm going to talk about a project that I've been working on, which is networking deep dive and hands on with a project that I was assigned by Tech Link Solutions, which is a mid sized company that wants to build a scalable, secure, and efficient office network. To do this, I was tasked with segmenting the network using subnets, enabling seamless communications between departments, and preparing the network for future expansions and reducing waste. So they required that we use IP range 192.168.0.0/24. We had to create subnets for the PC, printers, servers, and router to router communication. We had to use DHCP for dynamic IPs and static IPs for infrastructure devices. And we had to implement RIP Volume 2 for dynamic routing. So, with all that said, after we do all that, we're just testing and verifying the full connectivity across the network, and booyah, we did what we came for. So now I want to show you how I accomplished all this. So first off, I'm going to go and show you Cisco Packet Tracer. So in Cisco Packet Tracer, I basically pulled out two routers, router 0, router 1, two switches, switch 0, switch 1, and 6 PCs. I've connected the switch 0 to the router 0. I connected the PC 0, PC 1, and PC 2 to the switch 0, and also connected PC 3, PC 4, and PC 5 to switch 1. So to do kind of what they alluded to and kind of what they wanted, I basically simulated tech solutions being two sides of the fence with two different departments. The sales team on one side, which is the router 0 side, and the marketing team on the other side. It really doesn't matter which side you're on, as long as because with the way everything is formatted, PC 0 is going to be able to talk to PC 3, which is on the marketing side, and PC 5 will be able to talk to any of the PCs on the sales side. So I'm like, it doesn't matter which side you're on, everybody has communication and everybody's kind of using the same information. So, woo, okay, now to start us off, basically, I have some notes up here that I'm looking at. So if I'm looking away, please know that's what I'm looking at right now. Okay, so anyways, so to start us off, basically I basically inputted the router 0 information and the router 0 information into the switches using the corresponding cables. So you can use automatically choose like cable types to connect everything together. On the straight black lines, you're looking at the copper straight through cables. On the squiggly lines, the like bars right here, you're basically looking at the copper crossover. So two different. And so the from what you're seeing right here, those are two different bars that you're seeing right there. Those are what the different bars indicate. So, all right. So let's talk about the configuration of router 0. So on that one, I basically did the interface with a gigabit internet. There's basically entering in the IP address, which was IP address 192.168.0-1 with its own submask number. I put no shutdown, so it always ran continuously, so you wouldn't have to worry about that problem. I did the interface with the gigabit Ethernet 0/0/1 with its own IP address, which is very similar, except the last three digits are 0.29, and that has its own submask with no shutdown as well. So yeah, so I did the same exact thing with the router 1, except it had its own different numbers. The IP address for gigabit 0/0/0 ending in 0.65 with the gigabit interface of 0/0/1, that IP address ending in 0.30. So no shutdown on both of those either, because we wanted those to stay up continuously and always be running there. So here we go. All right, so basically we had the two sides of the fence that we set up. We wired everything. Now we're going to be talking about we talked about the router configuration with how we configured that out. Now let's go with the DHCP, which is basically the server and the routers are giving the PCs each their own number, their own IP addresses. So to configure that on the IP router, we basically entered in the excluded address. We did the IP here. Maybe I could pop it up and show you real quick. Give me 1 second. All right. Me on that. Boom, boom. Give me one. Let me look at it and see. Excluded. Is that the part where we did that? Okay. So yeah, here we go. So to do that, we basically had to configure the IP address to use the DHCP pool lane 1 and pool for the IP0 and pool lane 2 for IP1, which is basically means when the computer starts up and it asks, "Can I have an IP address?" Your router's gonna be like, "Yeah, man, I'm gonna hook you up. Here's your IP address," because that's what we configured with the DHCP. So then we wanted each router to basically communicate with each other, thus allowing all the PCs to kind of communicate within each router's network. So that's where RIP Volume 2 comes in. So RIP Volume 2 is kind of like each router basically telling each other, "Hey man, I have some information I wanted to deliver. If you need help, I got you." And after you enter in the router RIP version 2 on both routers, by the way, no auto summary and and you basically give it the network number. In this case, it would be 192.168.0.0. Now both routers share what they know, so all devices can basically talk to each other. They're on two different sides of the office, sales team and marketing, but they both can talk to each other because of the way we configured RIP Volume 2. So, but every time we wanted to grow, we want everything to grow out. So every time we added a computer, it's going to be assigned its own IP address because of that process we just talked about. But there are some items that we want to stay stagnant, which or static, I should say, which means like we want that particular item to always have that exact same IP address. That this way the computers always knows where to find them. In this case, it would be the server, boom, 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 and the printer. So on the printer side of the fence, we basically configured and gave it its own its own static IP address right here. So that way the computer knows exactly where to find it across the network. So we did all that, and we always wanted to test everything out so that we know there's connectivity across the board. So for instance, I'm going to show you right here. So these are some pings right here. So this would be a ping to one of the other computers. This is a ping to one of the other computers. So we were just running some tests. This was one where the device was unreachable, so I had to go back and do some corrections to some errors that I had done in the process. It's a lot of learning, everybody. But we finally got it done to where like we were able to ping ping different places over and over again. And that's always nice because we want every device, no matter what department they're in, to be able to access the same information and to be able to talk to one another across the board. So yeah, that's kind of so we built out the network, and then we were able to talk with pretty much we were able to establish communication across the board. We set up the printer, we set up the server. So yeah, everything looks great. That if you ever need to simulate this type of activity where you're trying to set up an office and you're trying to set up an infrastructure and you're trying to make it as efficient as possible, you can use Cisco Packet Tracer to do that. And through this exercise, man, I learned a lot. Absolutely learned a lot. But anyways, so that is Cisco Packet Tracer. That is me configuring out the networks. I also have a PDF attachment that you can see all the ins and outs, all the basically all the inputs that I put into router 1, server 1, or server 0, router 1, and you can see the screenshots of the PC different connections and the ping test there. So I wanted to keep this brief and kind of give you an overall summary of everything that went down. I've been Sebastion. Have a great day.